hundreds of millions of years, Pangaea had split apart and its jigsaw pieces had drifted to their present locations. Wegener called his theory continental drift. Wegener wasn't the first scientist to speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it. Unfortunately, his peers weren't very receptive. There was no mechanism to explain how the continents might plow through the oceans. Continental drift was just too incredible to believe.
The heart of the Earth, its inner core, is a solid ball of iron and nickel. Here the pressure is so high it never melts, despite the intense heat of 3,700 degrees Celsius. The outer core is under less pressure, so it is molten. This is enclosed by a deep layer of hot rocks called silicates. This is the mantle, and it's 3,000 kilometers thick. The surface is hard and forms a solid crust. If the Earth was a peach, this crust would be as thin as its skin. The Earth's crust is cracked and brittle, like an eggshell. It's made up of several segments called tectonic plates. There are two kinds of crust. Continental crust forms the great land masses of the world. This is thick. These rocks are made of ancient lightweight substances like granite. Some were formed almost 4,000 million years ago. Oceanic crust, which lies under the planet's great oceans, is much thinner. Oceanic rocks like basalt are heavy and much younger, 1/20th the age of continental rock.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart, and it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere during an eruption. The remarkable cycle is complete.